Hello everyone, my name is Vimal and I'd like to welcome you all to the final presentation. For my project, I used the data log terminal example that works with the STM32 workbench and the GCC compiler. I modified the example to add FreeRTOS to that so that I can get multi-threading to work. To explain what changes I had to make to get FreeRTOS running in the data log terminal example, I'd look to show you a file comparison between the original data log terminal source and my new source. The first things I had to modify was to change the HAL configuration a.h file to enable the timer timer module. At the same time, I had to modify the STM32 interrupt.c file to add support for the timer1 interrupt. And I also had to modify the systic handler to call the OS systic handler. The next step, once I had the FreeRTOS running, was to get the sensors up and running. Basically, read the data from the sensors and also implement the sensor fusion algorithm. So the first step that I decided to do was to get the UART running. For that, I first kind of defined an interface for the UART called as the UART interface. What essentially it is, it's a set of public APIs that other modules can use to be able to communicate with the UART. In my case, I have every module that I define a power up init and a power down function. I don't have one for the power down here. Like power up is mainly used to set up stuff at the very beginning before we actually start using that module. Initialization can be a set of sequences that we should go through if we have to reinitialize the module or it's initting for the first time. The other is a set of public APIs that a module can provide so that the external modules can talk to it or communicate with it. Like in the case of UART, I have a UART write data interface, which sensors threads can use to be able to write data or debugging information through the UART. The next step towards getting the IMU working was defining the implementations for each of the sensor thread. My idea here is each sensor thread, like in this case Axel, the gyro and the mag sensor threads, would read data from their respective sensors for in a specified time frame. They would give it to the sensor fusion interface. The sensor fusion internally has a queue, and each queue has a particular data structure type. Like in this case, it has a sensor ID, timestamp, and the type of the data it holds. So whenever the reader thread or the sensor, let us say the sensor gyro reader thread would call add gyro data API, it would timestamp that incoming data along with assign it an ID, like in this case the gyro ID, and then add it to the queue. The sensor fusion main, on the other hand, would read that data, get that data off the queue, and once it thinks it has the valid Axel, gyro, and mag data, what it would do is it would give to the Madvik AHRS update API. Internally, the Madvik AHRS update API would compute the quaternion data and set that data in the sensor fusion API. So my idea is the sensor application would get that data or the quaternion data from the sensor fusion get quaternion data API. So the Madvik's AHRS update would set the data, and the sensor display application, which updates the data for the user, would get the data from it. So because these both like the sensor fusion and the sensor display are working trying to access a common piece of data, that data is semaphore protected or mutex protected, so that it doesn't get corrupted when one is trying to read them and the other is trying to update them at the same time. So apart from this, the main important things that I had to do to this project was add support for the Adafruit LCD driver. I kind of followed the same interface example as the XNucleo IKS sensors. So like I defined these 4 different implementations, like 4 different levels of a. So my high level driver would provide APIs to be able to init the display, de-init the display, enable and disable the display, and also fill a rectangle, fill a screen with particular color, set a pixel, draw a vertical line, and draw a horizontal line. And on top of that, I defined a display interface.cpp, which an application at the upper level, like in this case the sensor application, could use to control the display, write data to it, etc. So what I did is I defined graphics interface.cpp. This is all based off the code that we used from on the previous course. So the graphics interface would provide APIs to be able to draw a line or draw a rectangle, draw a character, something, and other important graphics related stuff, print string to the LCD. And I defined another interface to display the UI, like UI related control, like a text box, like a label, button. So I have a user interface which defines objects like a UI button, a UI label. So what my sensor application does is on init, it will set up my user screen with the required label, initting the labels with the required, you know, uh, state variables like the dimensions, strings, color, foreground color, background color, and once every second or once every half second, the display application or the sensor application would get the data from the sensor fusion interface and update the controls accordingly. Now I'd like to go over a few issues that I came across when developing this project and how I resolve them. The first thing being formatting a float value and displaying it in a decimal format to the UART terminal. So for that I did a little research over the internet and found out that I could modify my MCU linker miscellaneous settings and add uprintf float. And since after doing that, I was able to get floating point values to display properly on the serial port. Another issue that I came across when working on this project is my I2C data was getting corrupted and my system would sometimes just hang up. So on debugging, I found out is like I had three different threads trying to access the I2C bus at the same time, and I saw that the I2C interface was not thread protected. So I modified my sensor IO read write interfaces to be protected by mutex, so that only one reader thread was getting ownership of the I2C bus. Now I would like to show you a small demo of my project.